A solid body rotates about a stationary axis according to the law phi is equal to at minus bt cube, where a is 6 radians per second and b is equal to 2 radians per second square. Find the mean values of angular velocity and angular acceleration averaged over the time interval between t is equal to 0 and the complete stop. The angular acceleration at the moment when the body stops. Suppose this is a solid body and this is rotating about some axis. This is the axis of rotation, and it is following this law of angular displacement phi is equal to at minus bt cube. What we have to find out? We have to find out the mean value of average velocity. For that we need the function of average velocity, and we have to find the mean value of angular acceleration. For that we also need the function for angular acceleration. Now the formula for average of angular velocity, so you can represent this by omega and bar over it, or you can represent it by this, or you can represent like this, one and same thing. So it is equal to integration from 0 to the time, which time taken by the solid body to come to complete stop, and this integration of omega dt divided by 0 to t dt. Similarly, for alpha, the angular acceleration, average of the angular acceleration, we can write it like this: 0 to t alpha dt divided by 0 to t dt. Clear? So in order to calculate this average, we need this omega. For omega, we have to differentiate this phi with respect to time, and we will get omega. So the rate of change of angular displacement with respect to time gives us omega, and we get a minus 3bt square. So we have this omega, and if we differentiate this omega, we will get this angular acceleration. So this is d omega by dt, and it is equal to minus 6bt. Clear? Now before we substitute this value of omega and alpha in both these formulas, we also have to find the value of t at which the solid body comes to complete rest. For this we put omega is equal to 0. So if we put omega is equal to 0, we get t equal to under root a by 3b. So this is the time at which the rotating body comes to complete stop. So we have to average this omega and alpha from time t is equal to 0 to this time t. So omega average is equal to 0 to this time, that is under the root a by 3b, and omega, we know this is omega, a minus 3bt square divided by integration of dt, because we have to average over the time 0 to this time t, a by 3b. Clear? So from this we get, this is dt, so we get at minus 3bt cube by 3, and the limit is from 0 to under root a by 3b divided by t, and limit is from 0 to under the root a by 3b. And if you solve it, you will get omega as 2 by 3a, and we know the value of a. The value of a is 6. So from here we can write omega as 4 radians per second. Clear? So this is the average of omega. Similarly, for alpha, for this angular acceleration alpha, we can put 0 to t. T is under root a by 3b, and alpha is minus 6bt dt divided by dt 0 to under root 3b. Clear? And if we substitute the values and integrating it, we get minus under root 3ab, and its magnitude can be written as the value of a is 6 and the value of b is 2, so it is equal to 6 radians per second square. Now in B part, we have to calculate the angular acceleration at the moment when the body stops. So we have calculated the formula for angular acceleration. That angular acceleration is equal to minus 6bt, and its magnitude will be plus, and we have calculated this time t also. So if we substitute the value, we will get this alpha as 2 under root 3ab, and 3ab is 6, so it is, and this is equal to 2 into value of under root 3ab. Value of under root 3ab is 6, so this is 6, so it is equal to 12 radians per second square.